Welcome to our previous class. We were discussing about of that vibrating rotor. So we will discuss today class is topic on diatomic molecules. Diatomic molecules. So if I talk about of this says diatomic molecule means like examples or like HCl or like O2 or like H2 or Cl2. This type of molecules where two atoms are there, and this is linear molecules. Obviously that only two atoms are there. Let's say one atom is here, then other atoms is here. So for representing these diatomic molecules, only one axis is needed because this is comes all in the one line. So it may be this line because two atoms are there. So for representing representing this type of diatomic molecules, only one axis needed. Now, if I talk more on it, this before discussing more about it, let's say that diagrams we will discuss. So let's say this is b equal to 0 to b equal to 1. So within vibrational there is a lot of rotationals will be there, like this. Here also a lot of rotationals will be there. This is j equal to 0, j equal to 1, equal to 2, like that. Here also j equal to 0, equal to 1, j equal to 2, all that. And this in which is b equal to, sorry, this is b equal to 1 and which is b equal to 0. Okay, and this lower energy what you are representing j double dash, and for higher energy that is b equal to 1 we represent as j dash. Okay, so now if I talk about that delta E, that is equal to E b equal to 1 minus E b equal to 0, and E is what? That is E rotational plus E vibrational. And one more thing, that we know that this also we can write this E rotational means b j plus 1, and E vibrational means b plus half omega minus b plus half square omega xa. Okay, so now if I write for these equations, how can I write delta E? If I want to write, then how can I write? So I will write first b1, after that minus of b0 I will write. So if I write for b1, then how I write? B for b1, this is z dash. Here we say that for b1 it is z dash, and for b0 it is z double dash. Some things I will put here. So b j, so 1, so double dash, this is for, first I will write for j1 and after that j0. Okay, so this z dash plus 1, after that I will write plus, this is for rotational, and vibrational I can write b plus half omega naught minus b plus half square omega naught xa. Okay, and this is for b equal to 1. Okay, so I will write here, this is for b equal to 1. Now I will write for b equal to 0, that I will write now b equal to 0, this become b j double dash and j double dash plus 1, and with that this is for rotational, vibrational, again I will write this is plus, that is I can write b plus half omega naught minus b plus half square omega naught xe, and this is for b equal to 0. Okay, so if I write it, delta E, so this one how I write, b z dash plus 1. Okay, and this is 1, so I will write here plus, I will write here 1 plus 2 omega naught minus, this is again so I will directly write the values. So b plus half, this is 1, then 1 plus 1, that is 2, 2, that is 3 upon 2, 3 upon 2 omega, and minus, this is equal to 9 upon 4 omega xe. Okay, and this value again I write this b j double dash plus 1, and this value is how much, I write this is 0, so this is become 1 upon 2 omega, and this is minus, this is 0, so 1 upon 4 omega xe. Okay, now I will write delta E, so these values I can write b j dash plus 1. Okay, and I can put this values is, I can put this value and this value nearby, so I can write this one, so minus, this is minus b j double dash plus 1. Okay, now I will write this one and this one, so that is plus 3 upon 2 omega, and this is minus, again this will become minus 1 upon 2 omega. Okay, now can I write this value and this value near, so I can write minus 9 upon 4 omega xe, and this is minus become plus, so plus 1 upon 4 omega xe. Okay, so if I put this, let's say this value is, so can I write this value first? Let me write this value, after that I will write this value. So if I write these values, so 3 upon 2 omega minus 1 upon 2 omega, that will become omega, and this is becomes how much, minus 8 upon 4 omega xe, that is become 2 minus 2 omega xe. Next, after that I will write this value b j dash plus 1 minus b j double dash and j double dash plus 1. Okay, now this delta E is, I can write this, so omega then 1 minus 2 xe plus, can I write here this, I can write b j square plus b j dash square minus b j double dash square, and this is again become minus b j double dash. Okay, and can I write this value as omega naught? So if I write omega 1 minus 2 xe is equal to omega naught, then I can write delta E equal to omega naught and plus this one I can write, so everywhere b is there, so I can take b as common, then I can write g dash square plus dash minus b double dash square minus b, sorry what I'm writing, that is j double dash square minus j double dash. This I can write, so delta E this I can write delta E equal to omega naught plus B. So here if we take that j dash square minus j double dash square plus j dash minus j double dash. Okay, so now omega naught delta E plus B. So this one can I write, because a square minus b square equal to a plus b and a minus b. So this one I can write j dash plus j double dash and this is j dash minus j double dash. In this format I write, and this is still that is j dash minus j double dash. Okay, so now if you look it, then what you see that omega naught plus b. So this is common here, so can I take that one? So j dash minus j double dash common here, then what is left? J dash plus j double dash plus 1. So this I will take as an equations 1. I will take this as equation 1. Okay, so now why I am taking equation 1? Because you see that here I am doing the transitions here. Let's say this one. So I am doing the transition. This is b equal to 1 and this is b equal to 0. I am doing the transitions from here to here like that. So you see this is j equal to 0, j equal to 1, equal to 2, j equal to 3, and this is all I represent j dash, and this all I represent j double dash. This also j equal to 0, j equal to 1, j equal to 2, equal to 3. Okay, so now delta j means what? Higher minus lower, so j dash minus j double dash. Okay, so if delta j minus j double dash equal to, so you know that selection rule for rotational is, that is plus minus 1. That is the selection rule for rotational. So if it is that, then we can say that delta j equal to j dash minus j double dash. This is higher minus lower. This can be either plus 1 or minus 1. So if j dash minus j double dash equal to plus 1, it means it will start from 0 and come to 1. That is plus 1, because from 1 to this subtract, that has to be 1. Okay, so if then this has to start from 0 and to 1. Okay, so now that I am putting here that value, if j dash minus j double dash equal to plus 1, this is case 1, let's say case 1, because another case is j dash minus j double dash equal to minus 1, because delta j is plus minus 1 for rotational. Okay, selection rule. Okay, so now I am taking plus 1, case 1. What is the value? It will become delta E equal to omega naught plus B j dash minus j double dash, that is equal to 1. Okay, and now this j dash minus j double dash, how can I put this value? So see, j dash minus j double dash equal to 1. Then can I put this one? This is for, I am taking for this one. So can I put j dash equal to j double dash plus 1? Okay, so this values, so instead of j dash I can write j double dash plus 1. plus j double dash plus 1. I can put like this. So delta E is equal to what? Omega naught plus B, and this is 2 plus 2 j double dash. So here delta E is equal to what I get? Not plus 2 is common, so 2B, and here j double dash plus 1. So if I take j minus j double dash equal to plus 1, then I am getting this value. Okay, so omega 2b j double dash plus 1. Okay, we will do what it means. Okay, now I will take another case 2. So let me take the case 2 also. After that we will explain this. Now if j dash minus j double dash equal to minus 1, okay, then what will do? Delta E is equal to, I can write omega naught plus b, and now this value is this one, so j dash minus j double dash equal to minus 1. So that is equal to minus 1. Now j dash minus j double dash equal to minus 1. So I can write this one, j dash plus 1 equal to j double dash. So can I put these values here, j double dash value with these equations? Then here what is that? J dash is there, and j double dash is j dash plus 1 and plus 1. Okay, so now this delta E is equal to omega naught plus b minus 1, and this is become 2j dash plus 2. Okay, so here delta E is equal to omega naught plus b. So you can see that this is going to become how much? Minus 2j dash minus 2. So if I take minus common, then omega naught minus b 2j dash plus 2. So this value I can write delta E is equal to omega naught. So this I can take minus 2 also, I can take common b, then j dash plus 1. So this is the case 2, when case if j dash and j dash equal to minus 1. So what it mean, these two equations? Okay, so now what is said that we represent that equations again. This one I'm saying, this is another I will draw. Okay, so this is equal to b equal to 1, and this is b equal to 0. Okay, so now what you see, it is saying that this is equal to j dash minus j double dash equal to plus 1, and this is j dash minus j double dash equal to minus 1. So what it says that whenever j dash minus j double dash equal to plus 1, it means that this is j equal to 0, this is j equal to 1, this is j equal to 2, and this is j equal to 3. Similarly, this is j equal to 0, this is j equal to 1, this is j equal to 2, this is j equal to 3. Okay, so now whenever I say this is plus 1, means this from plus 1 means what? J minus j, this is the j, this whole is j dash, and this whole is j double dash. So j dash minus j double dash means if I take that equations, like here is 1 and it has to be 0, like this. Okay, this is j dash minus j double dash equal to 1. How? So this is 0 and 1, So from here 1, here 0, subtract it, then you will get 1. Okay, this type of all the transitions, like these transitions, or you can say from, if I start from here, then I have to go here, this type of transition. These are all ZS minus, this is 2, this is 1, this is 2, and this is 1. So 2 minus 1, 1. Okay, like that. If I do, let me erase it. If I do this to this to this transition, these are all ZS minus Z double dash equal to 1. This type of transition are here. Okay, so that transitions I represented by omega naught to be ZS plus 1, and we will represent all that. And let's look about of this transition where this is minus 1. In that case, how this will be 0 and this will be 1. Let's say this type of transitions. So here this is 0 and this is 1. So 0 minus 1, that is minus 1. Okay, or we can see this transition, these two, this transition, these are like that transition. Okay, so if I do this transitions here, the transition, this is, let's say b equal to 1, let's say this is b equal to 0. Okay, and this is, let's say j equal to 0, j equal to 1, j equal to 2, j equal to 3, and let's say this is also j equal to 0, j equal to 1, and j equal to 2, and j equal to 3, and these are all about of z double s, and these are all about of zs. Okay, so what it says here that one transition is delta, or delta j means z dash minus z double dash, that is equal to 1. Therefore that type of transitions are all transitions. If I draw by this picture, so this value, one value, this is higher and this is value is lower. So this type of transitions, these all are this type of transitions. Okay, another transitions are, let's say this is from here and this is go to the down, this type of transitions. Zero to, sorry, not this transition, sorry. I can do this type of transitions. So here 1 to 0, and this is 2 to 1, this type of transitions. This type of transitions are, but z dash minus z double dash equal to minus 1. So this type of transitions, how we represent this in that spectrum, let's say this is omega naught, and here I can write, let's say I am writing here, this is starts from R0, R1, R2, R2, R3, let's say its intensities are like this. Another transitions are, let's say P1, P2, P3, P4. Its transitions are like this. like that type of transitions. So what we see here, that this j dash minus j double dash equal to 1, this type of transitions are started from j equal to 0. This started from j equal to 0. So, and these are positive, so positive we are writing in R branch. These are the R branch. Okay, and whenever I am writing from j equal to 1 to j equal to 0, that is j dash minus j double dash equal to minus 1, that I am writing, and this is started by from j equal to 1, so this is starting from 1, so this is start from p. Here, since this transition is starts from j equal to 0, that's why this starts from r0. Why we are starting, this is r0 and there is p1, not here p0, because transitions starts from j equal to 0 to j equal to 1. That's why we say that this start for r0. But whereas here, for this type of transition, it starts from j equal to 1 to j equal to 0. So it starts from with the starting position. This is j equal to 1. That's why it starts from p1, because transitions starts from j equal to 1 in case of p branch. Transition j equal to 0 to j equal to 1 in case of R branch. Okay. Now, whenever I put these values, let's say this one equation is this, another equation is this. So I'm writing these two equations here. The 2b z dash plus 1. One equation is delta A is omega naught plus 2b z dash plus 1. This is the one equations where j dash minus j double dash equal to plus 1. Another equation is so let's I took this as minus 2b. This is j dash minus j double dash equal to minus 1. This equation minus 2b minus 2b. Another equation is omega naught plus 2b. Sorry, this is j dash. This is j dash, and this is j double dash plus 1, and this is j dash minus j double dash equal to 1. Okay. So now, whenever if I put the value of j, let's say j dash equal to 0, then what the value will come, delta E is equal to, so this value is 0, 0, 1, that is equal to omega this is omega naught minus 2b, and whenever j dash equal to 1, then this value becomes omega naught. So let's say this value becomes this much, and this is when and when j dash equal to 1, then delta E is value becomes omega naught. This is 1, 1, 1, 2 become minus 4b. So this value I'm just need to be look carefully this, and whenever again if I put j dash equal to 2, then delta E value will become omega naught, and this is 2, 1, 3, that is become minus 6b. Like that, and if that j dash is 3, then 3, 1, 4, 4 to the 8b, that is become if j dash equal to 3, then delta E value becomes omega naught, that is 314 minus 8b. Okay, so whatever is seeing that, so whenever you are putting that J dash values 0, 1, 2, 3, then we are getting subtracted. This is actually low light, this is low frequency, and here we are getting the high frequency. From this is U naught, we are subtracting the values. Okay, so this one values you are getting at minus 2b, let's say I'm 2b, and this is you are getting 4b, this is 6b, this is 8b, another we may get 10b, like that in a negative form. Okay, other case, for this case, if I put J double dash equal to 0, then what value we are getting? Delta E is equal to omega naught plus 2b, that is 0. So 0 plus 1, 1, so there is a 2b, and this is, let's say, one value, and whenever I am getting J dash equal to 1, then delta E value, what I am getting? Omega naught. So this is 1, 1, 1, 2, 2, 2, 4b, and J dash equal to 2, then delta E value, how much I will get? 2, 2, 1 is 3, 3, 2 is 6, that's omega naught plus 6b, and another J dash equal to 3, then how much I am getting? Delta E is equal to omega naught, that is 3, 1 is 4, 8b, so this values I am getting. Okay, so this value or positive values we are getting, this is 2b, this is 4b, 6b, 8b, and 10b, like that. So what we observe here is that so whenever you are this is the R branch and this is the P branch, and this here, that no transition is happening here, because if you look here, that why that no peak here, we will not peak, you will here we will not get any peak. The reasons is, see that according to J dash minus J double dash equal to 1, and another J dash minus J double dash equal to minus 1. So here transition is started from 0 to 1. Okay, so omega naught, this transition is possible only when that if you observe here, if that Z is equal to 0, then this is 1. So here how this transition, why that transition is not happening in omega naughts, because if you look it, so what that here the transition is happening from 0 to 1. Okay. So for the transitions to happen at omega naughts, what is needed? That here we should get omega, or here also we get omega. How get here omega? So here omega naught plus 2b z is plus 1. This is the equations. So for getting this omega naught, this for subtracting this whole value, how will we subtract? If z dash each becomes minus 1, if z dash become minus 1, let's say if z dash equal to minus 1, then we can get delta E is equal to omega naught plus this is 2b, and z dash is minus 1, plus 1, then this is 0. So 0 into 0, then we get omega naught. But is it possible to get Zs minus 1? So is it possible to get Zs equal to minus 1? This is Zs. So it is started from J equal to 0. So J equal to minus 1 is not possible because it is starting from J equal to 0. So what is say that Zs if minus 1, then we may get that delta E equal to omega naught because this whole value will get 0. But getting Z dash equal to minus 1 is not possible because this Z dash is started J equal to 0 to J equal to 1, J equal to 2. So it is not there J dash equal to minus 1. So it is not possible to get any transitions at omega naught. Similarly, if you look here, that how will get omega naughts? If this value is minus 1, if J dash is minus 1, then this is minus 1 plus 1, this becomes 0. So 0 into 0, then this also becomes 0. So if J dash if we get minus 1, then the transition is possible at omega naughts. But J dash equal to minus 1, is it possible? No, because J is started from 0. So J equal to minus 1 is not possible. That's why we will not getting any transitions at this value. Okay. So today up to this, in next class we will look more. Thank you.